imagine that as being a huge warehouse with a flat roof with a solar installation, and they have electric forklift trucks which are put to work during the day, and they are charged during the inactive night period. So this is typically what you would find without a battery storage. So you would have during the day a large excess of regenerative power, which needs to be fed into the grid because it can't be put to use. So it's sold at a low price and not productive for the company. Looking at a hotel, also with a large solar production, with a peak for breakfast and a peak for evening dinner, and a bit of use during the day with a peak at lunchtime. There also a lot is not being used. A dairy farm, assuming it's not such a huge farm where they have staggered milking cycles over the day, but let's assume it's a milking in the morning and once again in the evening, with rinsing and cooling immediately afterwards. That would be a typical profile in that way. So how to put this amount of regenerative produced electricity, how to put that to use? That's the big question. And this is a diagram which you find in many publications on the subject. It is in fact an adaptation of what you saw previously. What is done is this amount of electricity, which normally would be fed into the grid, is put into the battery and is being extracted from the battery at a point in time when the sun doesn't shine anymore or the intensity is less, and therefore shifting this production here to a consumption here in this field. Has this been more or less clear? Yeah, so I see a couple of yeses coming in. So if there are any additional questions on the principle, please don't hesitate to ask. So what kind of companies would be useful? I tried to select a bit from our UK references. We have here a college that had the intention of increasing the self-consumption, and the speciality of this product was that it incorporated even a CHP, combined heat and power unit. So it is in fact a combined self-consumption and external power source integration, located in Liverpool in the UK. These references are, by the way, available for download on the Tesvolt website, so neatly translated into English, ready to be used for you. Yeah, here is a picture of the inside, and you also have the name of the installer of this system. Capacity and power 134 kilowatt hours with a 60 kilowatt power, which means that it is one Sunny Tree Power storage that would be involved here. Peak load shaving. Peak load shaving is the second most important application. And the entry of discussion, okay, it's quite straightforward, to be honest.